Chris. Somebody has a question for Chris.
Just about a model uncertainty, actually. So which is something the parameter uncertainty. So typically in practice, people would calibrate, for this pricing of structured product. So whenever possible, they would calibrate on other options. So it means that it's not really a matter of trying to guess the realized volatility for the future, but more using the current existing implied volatilities from vanilla. So that's one point. The other thing, I'm not sure I've understood how you compute. So basically, you reduce your exercise problem by slicing just the intrinsic value dimension. And so how do you, I'm not sure I've understood how you compute exactly the exercise frontier in this reduced space. You tried different ones? Or?
No, it's what's happened is that you've taken the intrinsic value.
It's not on. It's not on.
Okay, whatever. It is on, yeah. Okay. You've taken the intrinsic value, right, and you've bucketed the possible values. You might have, say, 200 buckets, and so you do this pretend Markov calculation on it. You actually solve the optimal stopping problem for that scalar Markov process.
Okay, dynamic programming in one dimension.
Yeah, exactly.
Okay.
So at any particular time, you say, I take the observed value of the Markov process, I calculate the g of t xt, which is now a scalar, and I look at which of the intervals this scalar value falls into. And if it's in one of the stopping intervals, I stop, otherwise I continue.
The boundary itself, the boundary itself is obtained by maximizing the expectation, or?
Yeah, I mean the stop. We expect that in a problem like this that the boundary, the stopping region might be a half line, for example, but it doesn't have to be, and it doesn't matter. I mean, you solve the optimal stopping problem, and the stopping region is some union of these bins, right? They don't have to be contiguous. There can be gaps in it. It's perfectly possible. It's just a rule, and so to decide at any time whether we stop or not, we calculate g of t and xt. What is the value if we stopped immediately? If that value is in one of the stopping bins, we stop. Otherwise, we continue.
Okay.
But
I'll compare it. Okay, maybe the one to unless you have the other question I wanted to ask is can you improve the method by using importance sampling, Markov chain Monte Carlo, particle Monte Carlo?
Marco says I should say yes to that.
Okay, any other question for Chris?
No, so you managed to reduce, let's say, the dimension for 60 to 1. So you said in some cases, actually, you miss a relevant variable, like in the case of this the average. So maybe it's possible to do something kind of in between and to add up 1 or 2 additional state variables and still doing the same kind of projection on this kind of extended intrinsic value.
That's a very perceptive comment. And for the Bermudan Asian with the fixed strike, the one that was really bad, I mean, it's kind of clear that you need a two-dimensional process to catch what's going on. And I suspect if you did that, then the same methodology would work. But of course, it's a grubby business because now you've got to sort of slice up a planar region rather than a linear region, and you're going to get much poorer resolution for 200 bins. They're going to be big fat bins.
Actually, I guess that in your Asian Bermudan case, actually, you just need 2 state variables because your problem is Markov actually in
Indeed.
2 variables.
Indeed.
There's a question.
So, Chris, if you go increase your slicing, so you should probably get better approximation on one hand, but then you should be at the Markovian approximation then should be less and less reasonable. So there's an optimal choice of the slicing? of the bins? And
Well, actually, I mean, what I did was basically I let the data tell you where the bins should be. So I say I'm going to have 200 bins. I run a trial of 10,000 paths, and then I just take the quantiles of the the numerical value within the bin is just the middle point of the sample within that bin.
okay. So
It's
a
crude,
question.
but it seems to work, and it also saves you the issue of having to scratch your head in advance and try to decide where to put the bin boundaries.
Okay, so
Any questions
let
for-
the data.
Questions for Jean Mungal?
I have a question for Chris, though.
Okay.
Yeah, I was just wondering, could you use this the methodology in a recursive manner, like for entry-exit problems or multiple stopping problems? Is it going to be amenable to that? Because then the rewards are not the same when you stop, right? I don't.
Yes, I think that
But
probably...
they'll still be reduced to one-dimensional
Yes, I
problems.
think that probably would work, because, I mean, ultimately, if you've got, say, if you're allowed to, say, exercise 4 times between now and expiry, it's essentially, it's a stack of 4 problems, isn't
that you
it?
should,
So-
be, in the, yeah. Good.
Okay, I guess now there's another person here. Is there more questions? Yes. It's nice to
Okay,
hear questions.
it's for yes, for Sebastian. You call it a model uncertainty. Is there any
Yeah.
relation with model risk? Could you measure the risk of considering one or other measure? How do you find this?
Could you consider the risk of one model versus another? Well, okay, let's see. I'm thinking about it the perspective
I'll
from,
tell you the risk. I can answer that. If he does a call
okay, he's going
spread,
to answer the question.
if he does a call spread and he makes a price which is risk averse,
Yeah.
then he'll never trade with anybody. If he does the other price, then you can actually pick on him because everybody can, options are priced to the forward mathematically, unless they're options sold to little old ladies. But, but normally an option, there's put call parity. A market without put call, is there put call parity on electricity?
Of course.
Okay,
On
so
options,
then
yeah.
you can take out that ambiguity about the drift, because put call parity says the forward is given, right? So
There's still going to be a bit-ask spread. Give me any answer. There's
that
a
is
bit-ask spread.
absolutely
And
true.
that's
absolutely
where
true.
that spread comes
But
from
that's not
partially.
how you. That's not. Is that what you meant?
It partially comes from there. Yes.
Okay, so model risk is you get caught into an option that you can't get out because of the bid-ask spread. No,
What's that?
He answered it.
Yeah.
I'm just trying to.
It's like, okay, fine.
I have a question to both.
You have a question for both.
Yes. Oh, yeah. Of course, come on. But not to Marco. Well, Marco too.
He'll
Just
answer.
kidding, Marco. Just kidding.
We'll just
Have
go
our
back to the
version,
audience
then
and
it'll
have.
So, my question is, let me phrase it starting with Sebastian. We both have worked in real options, even together at some point. And could you try to phrase this model ambiguity in this context of real options? And then the continuation to Chris.
Actually,
Assuming
yes, you can.
Yeah.
And I have something on that in the diffusive case.
Uh-huh.
In fact, real options with ambiguity and irreversible investments and how it affects your exit and entry strategy. Yeah.
And then continue on to the question to Chris. The question to Chris is, assuming then you want to find the optimal stopping time under a situation where you have very few simulations given to you, could this be somehow applied to the so-called real option valuation, where the investor gives you simulations of cash flows, for example? Do you envision some kind of approach like that?
I think that will be hard to do, because kind of central to the methodology is that you know how to simulate the evolution of the Markov process, and a sort of situation where you're given 200 scenarios. I mean, in a sense, you don't really know that. You're simply given a small number of sample paths, and you don't know what might have happened on other sample paths. I think you'd have to look pretty hard at the methodology. I think it would be hard.
Okay. Well, yeah, perhaps we can talk about that. Yeah, I have some ideas, and actually in my talk I'm going to discuss a little bit that. Okay. Well,
More questions? Yes.
Okay, so the question was, how do you get the hedging strategy? Okay, so that sort of goes back to this earlier work on the dual approach to the optimal stopping problem. And remember I mentioned there's a sort of magic martingale that does the job. Well, the idea is that martingale is the hedge. So we typically think of an American option from the seller's point of view, that there's this random process, and when we stop it we get whatever it's going to be. But if you think of the dual form of it, what the dual form of it is actually saying, it says if we use this martingale as the hedge, then whatever time the guy exercises, we are able to pay our obligations because of that pathwise sup of G minus M. So the martingale that comes from the dual approach is the hedge. Now we're only sort of carrying out that calculation in an approximate way because it's a difficult problem, but we do come up with a quite explicit martingale, which is the martingale part of our supposed value function, and that is the hedge.
So when you say hedging, it's not like a trading strategy.
Sorry, it's not.
You're not talking about a trading strategy as a hedge.
Well, you'd have to translate it back to what does this mean in terms of the traded assets. So you have a martingale difference that you're going to try and generate over the next day, and there would be a step. If you're actually going to implement this, you'd have to say, well, okay, what linear combination of traded assets should I take today that would reasonably closely approximate the martingale difference I would like to realize. Yeah.
More questions?
Coffee.
Okay, Sebastian, I have a question for you. Actually, I have an assignment for you.
You have an assignment for me.
The assignment is this. First, you have to pick a price for the forward,
Yes.
so the
okay.
first
Sure,
product.
sure.
Then you calibrate the model. You do the same problem, but constrained that you have the correct value
So
of
you
the
have the correct
forward.
forward price. Okay.
Then you price the option. And in
Yeah,
that
this is
case,
a different problem.
yes, it is, and I know it's not. But then the yellow part in the call spread, the white part
The
in
white
the
part
middle
might.
will disappear, and it will
yeah.
become cyan.
Yeah.
It'll turn from white to blue, because the only problems arise at near the strikes. That's where Vega.
Sure.
If there's
Sure,
something
sure, sure.
called Vega that
Yeah.
us old timers talk about. Vega.
I've heard of Vega.
And then Vega, you have Vega on the red. The red parts are
I
where
watched
Vega is big.
Star Trek as
Yeah.
well.
So, but because you don't pin the forward, and this is the remark that I want to
Yeah.
make, in the call spread, the first slide, the white it means that you have a lot of payoff if you ever make it there with the.
Yeah.
So you see that's why it's white, and then so that's because of, and then the other thing, so.
Yeah, it's
And it's not skewed.
We're not
a lot
pinning
of
the
people,
forward correct.
a lot of people confuse.
Yeah,
a lot of
yeah.
traders think that they shouldn't put the options in the forward, but the way that the market deals with skewness in the distribution, it first calibrates to the forward,
Yeah.
and then they call skew the difference in price between out of the money calls and out of the money puts. But if you don't calibrate to the forward, it's not skew. It's that you're not risk neutral pricing, risk neutral in the sense that.
in the classical
In the
risk
sense of
neutral.
forward
Yes, yes,
pricing
yes.
adjustment.
Sure.
You agree? Thank you.
Homework.
It's not a homework. You should give me homework. Any other questions for these two very interesting talks? Are we having drinks now or more talks?
No, I just have announcements. So, well, first of all, perhaps we should thank the speakers and the chair